Hey everyone, today let's try to solve another LeetCode problem. I know, right? What a surprise. Today's problem is called minimum operations to form subsequence with target sum. In this problem, you are given a zero-index array nums consisting of non-negative power of 2 and an integer target. In one operation, you must apply the following change to the array. You either choose any element of the array nums such that nums I is greater than 1 and remove this nums I from the array and then add 2 nums I divided by 2 at the end of the nums, and we want to return the minimum number of operations that we need to do so that the nums will contain a subsequence whose the element sum to the target. And if it is impossible to obtain such a subsequence, then just return -1. So let's take a look at the example to illustrate the idea. So in this example, you are given nums 1, 32, 1, and 2, and the target is 12. So in the first operation, we can choose nums1, which is 32, and then we remove 32 and add 216 at the end of the array. And on the second operation, when we choose nums3, which is the fourth one, so this 16, and then we remove this 16, and 16 divided by 2 is 8, so we add 8 at the end of the array and remove this 16, so we get this 1, 1, 2, 16, 8, 8 array. And now notice 1, 1, 2, and 8, they actually sum up with 12, and which is also our target. So that's why in 2 operations we can obtain what we want. So that's basically all of the program description, and let's see how can we actually solve it. Still looking at the same example, but instead of just look at the target like 12, we can look at like in a binary number. So in a binary number, the first bit is 1, second bit is 2, and third bit is 4, and 8, 16, 32, 64, etc, etc. And if we look at the target as 12, and the binary number is just 4 plus 8. So it's 1, 1 here, and then 0, 0 here. This is the binary number of our target. And also, if we look at the nums, in terms of the occurrences of each bit, and will give us more clear idea what to do. We can convert these nums to, for example, this 1 and 1 appear twice, and this is 2 here, and then 2 appears once, so it's 1 here, and 4 appeared 0 time, and 8 appeared 0 time, and 16 appeared 0 time, and 32 appeared 1 time, and 64 appeared 0 time. So with this helper array, we want to achieve the target sum. If, for example, this 2 is 1, then we don't have to care about fulfilling this 2 because we have the occurrences of 1 here. We can just use it. But the problem occurs when the target wants a 1 here, but we don't actually have the occurrence. For example, we want a 4 here, but we don't actually have a 4. So there's 2 ways to do it. One way is to use this 32 and then make it to 16 and for 1 operation, and make it to 8 for 2 operation, and make it all the way to the 4, which, as you can see, the operation is the distance between 4 and 32. That's one option. Another option is that if you notice 2 plus 2 will be equal to 4. So it means that if there is 2 or more occurrence of 2, then we can actually combine them in 4. But wait a second, we don't have an occurrence of greater or equal to 2, but we have the occurrence of 1 being 2, which is greater or equal to 2. So basically 2, 1 combined, and we will make this to 0, and this will become 2. And because these 2 can also combine, and this will become 0, and now this will become 1, and we can achieve 4 in this way. So there's basically 2 ways we can fulfill 4. So one is from the right and one is from the left. So if you think about it, it is always better to fulfill this 4 from the left hand side if possible. Because if you fulfill this from the left hand side, it doesn't have to do any defined operation. But the prerequisite is that it has some extra 1 that we can use. For example, if it is 1 in here, we cannot use this extra. So basically, if there is something extra on the left hand side, and we want to use that left hand side. So if there's nothing on the left hand side, we're going to have to use the right hand side. If there is no left hand side and no right hand side, identify for us to do, and it just return -1. So that's basically the flow. And each time we want to see how many extra that we have. So extra means the target need and the occurrence. For example, originally it is 2, 2 minus 0 is 2. It means that it has an extra of 2. And first thing, we're going to check if there's anything on the left hand side that we're gonna fulfill. And if there's nothing left hand side that we want to fulfill, then we want to make this 2 go to the next count. So in this case, there's nothing on the left hand side to fulfill. Because if there's something on the left hand side, for example, you can imagine there's 0 and 0 here. There's maybe some 1 here. And by the way it reached 32, and I can sort of know that there is something on the left hand side that is not fulfilled yet. So it means that I have to do the divide to 16 and 8 and 4 in order to reach this stuff. And I want to do it as soon as possible, because in the later, for example, here might be 256. If I do the divide in here, the distance is going to be longer. So as long as I have the extra here, for example, this should be 0 because there's no 32 bit on target, so it has an extra of 1. So it's just going to fulfill this to the left hand side. But if there is nothing fulfilled on the left hand side, for example, in here, this 2 does not have anything to fulfill on the left hand side, and I have an extra of 2, so I might as well just make this to 0 and add extra divided by 2 to count plus 1, which is 2. So this will become 2, and then this 2, look at the left hand side, nothing to fulfill, and then just remove this 2 and add extra divided by 2 to the next one, which is 1. So 1, now the extra is 0, so we don't have anything else to do. We have to fulfill this target, and we don't have extra to pass to the next, or we don't have anything else on the left to take care of. And in here 8, we can see the extra is negative. It means that we require something, but we don't have enough bit here. So we're gonna mark the leftmost in here, and then we're gonna go to the right, and it is still no extra in here, and we go to the 32, and then we're just going to have an extra now because 1 minus 0 is 1, so we have an extra that we can spend, and the way that we spend it is just divide 32 to 16, so this becomes 0, but everything else here will be 1. So that's why I say we only care about the leftmost, because even if there is something extra in here that we want to fulfill, then we're just going to fulfill the leftmost. And while doing the leftmost, this unfulfilling target will automatically be filled. So, but in order to fulfill this leftmost, we have to do the position of this. The distance of these 2 is going to be 2, for instance. So this answer plus equals to 2 because the distance of these 2 position is 2. Then we just can keep going until we iterate all the bit in the target, and we can see there's no more unfulfilling thing. And we can mark leftmost to back to something like -1 once it's done. And if we finish all our bit, like in the 32 bit, and the leftmost is still not equal to -1, it means that we have something to fulfill, but we fail to fulfill it, and we just return -1. Otherwise, we just return this answer, which in case which is 2, and 2 is the correct answer here. So that's why we can solve this problem in this way. So that's pretty much all for the solution overview. Let's see how can we code this up. So before we begin, just have to write two helper method. And the first helper method is going to get the position of the x and where x will be a power of 2. For example, if the binary number of the x is like 1, 0, 0, 0, and we should return 3 because the first here, which is 0 index, and it's 1 index, 2 index, this is 3 index, and if the binary number is something like 1, 0, then we should return 1 because this is the 1 index of it. So basically just returning the position of that power of 2. And the second helper method is the basic, it basically just returns the binary number in an array of integer with either 0 or 1. And after having these two helper methods, we're going to have the counts, which will tell us the occurrences of each power of 2 from the nums. And then we're just going to iterate every value in a nums and then just get the position of this power of 2 number, which is x, and then just add it by 1. And after having the counts, then we can iterate first a bunch of variable. B is the best in a target, and answer is the total operation that we have to do in order to fulfill target, and the leftmost is -1, which is the leftmost satisfied bit that we have to take care of, as we explained in the solution overview. So now we're going to iterate every bit on the counts, and we're going to check the extra. Extra means anything that is more than needed, then we can share it to the left or we can share it to the right. So the way to do it is just the counts of I minus 0 if I is greater than or equal to the length of b, and otherwise we will just minus bi. So if bi is 0, then we minus nothing. If bi is 1, it means that this bit is required something. So if extra is less than 0, it means that this bit is unsatisfied. We have to do something about it. And if the leftmost is -1, it means there's nothing on the leftmost yet, and we just set it. Otherwise, we don't set the leftmost, because as I mentioned, if we fulfill the leftmost, this index I will automatically be fulfilled in the process of fulfilling the leftmost. And otherwise, if extra is 0, it means that it has nothing more bit to share to the left or nothing else to share to the right. So that's why we continue here as well. And first we're gonna fulfill the left first, because it is more urgent to fulfill it now, because if we fulfill it later, then the difference of the position is going to be larger, but we want to minimize the operation. So if we see something on the left hand side that we can fulfill and we can fulfill it, we have the extra, then we should fulfill it now. So the way that we fulfill it, as we mentioned, is just answer plus equals to I minus leftmost. And then after fulfilling the leftmost, then we can set the leftmost to -1 and the extra minus equal 1, because we can just use one bit and fulfilling the leftmost, but using that one bit will make the extra become 1 less. So after becoming 1 less, and if extra divided by 2 is still greater than 0, it means that I can push something on the right hand side, and I plus 1 is still within the boundary, then we just move our extra bit to the I plus 1. But remember, 2 bit here means 1 bit on the I plus 1. So that's why we have to add extra divided by 2 instead of just extra for the I plus 1. So eventually, if the leftmost is -1, it means there's nothing on the left hand side that is still need fulfilling, then we just return the answer, which is the accumulate sum from the line 34. And otherwise, if there's still something leftmost that we have to fulfill, but we didn't fulfill that, but we have exhausted every count, and it means there's no way to fulfill this leftmost, then we just return -1. So that's pretty much all for the code. Let's try to submit that. Okay, accepted. So for the time complexity, it will be O n times 30, because it only goes all the way to 2 to the power of 30. So mainly coming from the loop here in line 20, we iterate everything in nums, which is O n, and for each x, we have to do this post, and for this post function, in the worst case, it will go 30 loops. So that's why it's n times 30, or we can just ignore it and become O n, because 30 is the constant. And for space complexity, it will be 30 because of the array in line 19, and also the bits array from target. And also you can say it like 30, or you can just treat it as O1 because it is also a constant. It depends how you explain it to the interviewer, or you can say it like a log x, where x is the maximum number of the array. So that's pretty much all for the solution. Again, I will post the text version of the solution in the description, and I'll see you next time. Bye bye.